What is a token cannon in BPMN? It doesn't look like a cannon, it doesn't make any noise, but it can silently destroy your process. Hi, my name is Andreas Hense and I make videos about business process automation. A token cannon in BPMN is not an official part of the BPMN specification. It is a part of a process model that can create an unbounded number of tokens. Let's go to the computer and I'll show you a few examples. So I'll now show you 10 different token cannons, and we start with number 1, the AND split. Token cannon is here. We start the token simulation, and now you can see that tokens are produced. There's this loop, and this token cannon cannot be stopped. A variation of this is with an OR split, of course, instead of the AND split. We have the token cannon now, and this behaves in the same way as before, but here we can actually stop this from going back, and so we have a way of stopping the token cannon. The next one, number 3 on our list, is with a boundary event. So here we have a boundary event, and in order to make that work, we have to put a pause here, start the token game, and now we can create as many tokens as we like here, and then we can fire them one by one until they're all consumed. The next one is a boundary event, but with a different construction here. So again, we put on the token simulation, put a pause here, and now we can emit tokens here until we finish this task, and then it's over. The next one is number 5. This is an implicit token cannon, so very subtle. Token simulation, you can see that there is this loop going on, and so this is an implicit AND split with an implicit XOR-Join, producing the token cannon here. You cannot stop this one. The next example is this one. It's also an implicit token cannon. It just looks differently. So we have this token going back and forth. So there are actually 2 arcs, and again, this is because of BPMN having implicit AND splits and implicit XOR joins when we don't use any gateways. This token cannon cannot be stopped either. So the next one, this is very similar, but it actually looks more like a cannon, but tokens going back and forth between task A and B, and it's emitting tokens one after the other and cannot be stopped. The 9th token cannon is this one here. So we started here, and you cannot really see that it's actually creating many tokens, but as soon as we change this gateway here, we can now see we have 128 tokens created here, and we can just fire them one by one from here. And the 10th token cannon is this one here. Put on the token simulation, put a pause here, and this is with a signal event. So we can imagine that we get a signal here. And actually, if we get another one, you can see that the signals are actually propagated from here to here. So we get many tokens here, as many as we want. And then we can just continue the case like that. Why are token cannons relevant for us? First of all, they are an anti-pattern. They destroy the soundness property, leading to multiple executions of paths in the process graph that comes after them. Usually, we want to avoid that. In certain business process management systems, they are also problematic in combinations with OR joins. There are, however, situations where they can make sense. I've seen that happen several times in industry projects. I made up a simple illustrative example which I discussed in an earlier video. I'll put a link to this in the description below. Thank you for watching.